Guys, welcome you all. Welcome to Unacademy. Welcome you guys. Welcome to this Kreatryx channel. Good evening, guys. Welcome you. Welcome you all. So, how you are doing, everybody? कैसे हो सभी लोग? So, I hope all of you are doing great and all. So, here first of all, do comment in the comment sections. First of all, do comment in the comment section. Is my audio video is clear, everybody? Do comment in the comment section. So is my audio video is clear to all of you? Tell me. Fine. Chalo. Let's continue our discussions. In the last class we have discussed about the method of images we have seen. All of you tell me. The last class we have did the method of images हमने complete किया. अगर कोई doubt हुआ तो so do comment in the comment sections. Let's have a discussions. Fine. Chalo. Now we have a great announcement. So you can see now the new batches we are starting. You can see now this Udaan batch. But this is batch for the GATE 2024 के लिए. So you can find the top educators team. You can find the top educators of Unacademy. You can find here, isn't it? And so the December 21st onwards we are starting the new batches. We are starting. And to avail this great discounts, you can use a code of B V Reddy. Use the code of B V Reddy to get the great discounts. With this you can have the great discounts of Minewala, and in addition to that my personalized guidance to the students. And so you can see now this batch for the ECE for December 21st onwards we are starting a new batch for GATE 2025 के लिए. You can find the top educators team. You can find here. These are the advantages of this new batches. You can see. So complete coverage of the syllabus by the top educators, and you can access the complete digital notes material. You can access. So more than 6,000, nearly 6,000 practice questions are there. Doubt solving, DPP, special classes, practice sessions by the educators. The best test series आपको मिलने वाला. And these are the new batches. You can see here Udaan batch for GATE 2024 के लिए. So these are new batches. You can see. Now these are the USPs for these new batches. And there is one great opportunity here. So here, as per the request, this offer which is extended up to this month end, up to 21st December, this offer has been extended. So you can utilize these opportunities by using a code of B V Reddy. Right. So now you can see this thing here. These are we have started the IRMS batches also, as you might see recently, and you can find the top educators here. Mission IRMS. Right. And so they chance to avail this as a 39% discount आपको मिलने वाला. You can utilize these opportunities by using a code of B V Reddy. And by using a code of B V Reddy, you will get the personalized guidance from me, and in addition to this, you will get the great discount आपको मिलने वाला. चलो, let's continue our discussions. And one more, the new thing here, so this is an all India mock test. So this is exclusively for the GATE 2023 students. With this mock test, by attempting the test series only, you will get to know your mistakes and all. So to know your mistakes and what you need to do here, do attempt the test series. Then you will get to know your mistakes and where your weak areas and what topics you need to revise, what are silly mistakes you are doing and all. And so Sunday we have, this is last Sunday which happened, and this next test series we have on 8th January. And don't forget, so do enroll for this link given in the descriptions. Do enroll, and by using the invite code, if they ask in the invite code, you can use the invite code as a B V Reddy. You can use the invite code of B V Reddy. And this test series is completely free of cost. Okay. Sure. Let's continue our discussion, all of you. Fine. Let's talk about the today's topic, that is a polarization of a dielectrics, and thereafter we will discuss the capacitance analysis हम discuss करने वाला. Okay, all of you, right? So here first of all, let us understand the difference between the conductor and the dielectrics. So conductor, it should have its charges, huge number of charges are available, free charges available, but in case of dielectric, charges are not freely available, those are bounded by the covalent bonds. Those are, the charges are bounded. Consider this is my dielectric material. Yes, consider this is my some dielectric material. Now see what's going to happen. This dielectric material will have a charges. The dielectric material we have charges, but those charges are what? How these charges are? These charges, it all will contains the charges we have, but the charges are bounded. And how the charges are? These are bounded charges. And when we don't apply any electric field, अगर हमने कोई electric field नहीं किया तो, when the electric field is zero, the charges inside this dielectric, those are arranged in a random fashion. When we don't apply any electric field, the charges inside the dielectric, those are in a randomly they will place. Now I have taken the same dielectric I have taken. अगर मैंने same dielectric ले लिया तो, now see what's going to happen. Same dielectric material I am taking. So now see here, now what I am going to do here. Now for this dielectric, now I am start supplying some electric field. Supplying the electric field. In this case, that means electric field is non-zero. And start supplying the electric field to this dielectric. So let us consider we are applying the electric field in this direction. This is the direction of electric field. This is the direction of electric field we applied. Now you tell me, now this dielectric also will contain the charges, but those are the bound charges. Fine though. And in case of conductor, we have free charges available. For dielectric, there is no free charges. Now you see this thing here. When we apply some electric field, so क्या होने वाला, either you tell me. Inside the charges, we will experience some force now. Since we are applying the electric field in these directions, let us consider we are applying the electric field in this direction. Inside the dielectric we have charges, there are not. Inside the dielectric we have charges is present now. The charges inside the dielectric will experience some force. The charges inside the dielectric will experience a force. Hana, boliye, tell me. And so now because of this force, what's going to happen, we are going to see. Because of this force, what's going to happen, we are going to see. Now here you tell me, now here what is the force acting on the charges, you tell me. The force acting on the charges, F is equal to what we can say, tell me, which is equal to Q into E. F is equal to what, you tell me now, QU into E. And the direction of electric field and force both are in a same directions. Both are in a same direction, right? Now can you tell me what is the direction, what is the force acting on positive charges? The force acting on positive charges, which is given as, for positive charges Q is positive, now tell me. That means we have the electric field force like this. Now you tell me now क्या होने वाला. And what is a force or negative charges, you tell me? The force are negative charges, which is given as minus q into E. Minus q into E. Boliye. That means the force acting on the positive charges, since we are applying the electric field is this direction, the force acting on positive charges is same as along the direction of electric field. The force acting on negative charges, what is the force acting on negative charges, is opposite to the electric field, and both positive charge and negative charge will experience a same magnitude of force, but directions are opposite directions. Hana boliye. So because of this force, what happens, you know, here all the positive charges, the positive charges will move along the direction of electric field. All the positive charges will move along the direction of electric field, and all the negative charges will move opposite to the electric field. Opposite to the electric field, they will move like this thing. Here for understand, so I have given only some charges only, but we have huge number of charges are there. We have a huge number of charges are there. I am taking only small some charges only I am representing, right? Now so here because of this, अगर आपने ध्यान से देखा तो here and this side completely positive charges will come. This side positive charges will come, and this side we have negative charges will come. Inside we have so many other charges we have, now tell me. Inside we have so many other charges are there. So now you tell me, now let us consider there might be some charge is there. Let us consider there is some positive charge is there. Here there is this positive charge. This positive charge, consider, let us analyze one by one. This positive charge, yes, will experience a force from this electric field. As a result, what happens now here? This positive charge try to move along the direction of electric field. This positive charge try to move along the direction of electric field. Hana boliye. So yes, now here, now if you see carefully, this positive charge because of this force will try to move this direction, and but lekin, so this positive charge will experience a force from already existing positive charge. Here already positive charge is there now. This charge will experience some force from already existing positive charge. And what is the force between these two, tell me? And what about the force between these two, tell me now here? Which is a repulsive force. Now this is already positive charge is there. This positive charge will repel this positive charge now. So as a resultant of this, what happens now here? This positive charge, because of the effect of this electric field, will try to move, but lekin already we have a positive charge is there. That positive charge will repel the charge, and in addition to this here we have negative charge is there. And this negative charge, अगर आपने ध्यान से देखा तो here, so this negative charge will attract this positive charge. This negative charge will attract the positive charge. Now if you see carefully now here, this positive charge, this charge will experience say three different forces we have. On this positive charge we have three forces are there. And you tell me, one force is because of this externally applied electric field, and one force is repulsion, this thing here, and one force is attraction. So that means what now here, whichever the forces will be dominating, according to that will move. And if you see carefully, and this repulsive force and this attractive force are both in same directions. And what is the direction of repulsive force now here? This direction. Attractive force is also this direction only now. This repulsive force, attraction force, both are same directions, isn't it? And so then now you tell me now here, agar, so this charge will try to move here, yes, but lekin because of these two forces are this direction, this force is this direction. Then see what happens now here. So this movement of charges will take place from one side to other side until so here these two forces and this force will be get balanced. Hana boliye. When the two forces, one side, the left side force and the right side force will be get balanced, equal, until that there is a movement of charges will takes place from one side to other side. Hana boliye. Let us consider here. So because of this effect of these forces, these many forces, now let us say my positive charge can able to move up to this much of distance only, and this is because of repulsion hoga na. And the same phenomena can be applicable for the negative charge which is present here. Let us say here we have negative charge is there. So tell me now here, now force on this negative charge because of this electric field is opposite direction, and because of this positive charge is attraction. As a result, this negative charge will be located here only, isn't it? And so that means these many negative charges will be accumulate now. Here we are indicating only small amount of charges. We have so many charges are there. Try to understand. Is it fine to all of you? Tell me. Now, as a result, you see what's going to happen. You tell me. Result, I formed, yes. As a result of this, a pair of positive and negative charges pairs are formed. If you observe carefully. As a result, a pair of positive and negative charges are formed like this. This pair is called as a dipole. This pair, which is called as a electric dipole. This pair is called as a electric dipole. All of you, these pairs are called as a electric dipole. The formation of electric dipole by applying this external electric field which is called as a polarization. The formation of this electric dipole by applying a external electric field is called as a polarization. Isn't it? All of you tell me. The formation of electric dipole by applying external electric field is called as a polarizations. Fine. The polarization means what? Formation of electric dipoles by applying external electric field is called as a polarization of the electric. Is it fine? Now, let us talk about the some more analysis here. Is it fine now? Tell me. Is it fine, everybody? Right. चलो. Now, so अभी हमने कुछ cost discuss करने वाला, आप ध्यान से देखो इधर. Everybody listen carefully. We are going to discuss some one important phenomena we are going to see. So this we have taken this as DC supply. And here our complete focus is about this element. What is this? You tell me. अभी इधर हमारा पूरा focus is about this thing here. ये क्या है बोलिए? What is this? You tell me. ये क्या है यार? So this का ये क्या है? What is this? You tell me. What is this element? You tell me. कैपेसिटर, यस द कैपेसिटर के बारे में डिस्कस करने वाला अभी। सो इसका कैपेसिटर के बीच में क्या आई, कैपेसिटर के बीच में क्या आई, सो दिस इज द कैपेसिटर प्लेट्स। सो कैपेसिटर बीच में क्या आई, सो वी हैव अ डाइलेक्ट्रिक। नाउ अभी देखो इधर, अभी देखो इधर, now you see this thing, this is the material which we have a dielectric. Now you tell me now here, when we don't, when the switch is not closed, when the switch is open, when the switch is open, the scenario of this thing is like this. You tell me, when the switch is open, the scenario is like this. That means no electric field is applied. All of you, no voltage given means no electric field is applied. Okay, this is the scenario, then there is no flow of current. So abhi dekho idhar, the moment let us say at t is equal to 0, my switch has been closed. If I close the switch now here, this is the positive terminal, here we have given a positive terminal, here we have given a negative terminal we have given. Okay, between the positive to negative we have a electric field, we have, yes or no, positive charge to negative charge, we have electric field will accumulate now. So we have the electric field. What's the direction of electric field, you tell me? The direction of electric field is from the positive to negative like this. The direction of electric field is from the positive to negative like this. Electric field is from the positive to negative. Is it fine? अभी बोलिए क्या होगा, you tell me. Because of this electric field, the positive charges will experience a force, now tell me, which is given as what I can say plus QE, and the negative charges will experience a force which is given as minus QE. So as a result, what happens, you tell me now here. So one side here, what are the positive charges we have this side, they will be, all the positive charges will move like this and all the negative charges will move like this. Now here you tell me क्या होने वाला इधर. So the moment when you supply the energy, so this all the charges will experience, positive charges will move this direction, negative charges will move like this. Now there is a huge flow of charges will takes from the one side to other side. बोलिए, huge flow of so many, so here crores of charges are there, those will be huge amount of charges will be flows from one direction to other directions. हाँ ना बोलिए, there is a movement of charges will takes place from one side to other side. So then tell me now, in the process of this thing, and there is a, when the charges are displacing, momenting, that means we have a current, we have a current, then after some time, if we observe carefully, and this side completely positive charges will come now here, right, and this side we have a negative charges will come here, and so even as a result we can form a pair of negative charges pairs formed, you can see, and these pairs are called as a dipole. Until the electric field, until the left side force balances the right side force, there is a movement of charges. Once the left and right forces are get balanced, then what happens now here, then there is no further movement of charges, there is no further movement of charges, then I can say that dipoles are formed. Then what I can say, then I can say that dipoles are formed. So there is a movement of charges will from one side to other side until the electric dipoles are formed. Once the dipoles are formed, there is no further movement of charges. There is no further movement of charges. If there is no movement of charges, I can say there is no flow of current. If there is no movement of charges means there is no flow of current. Hana boliye. If there is no current, so there is no flow of current. Now you tell me now here, now you tell me, try to understand. So here at t is equal to 0, I have closed my switch. Now you tell me now here, there is a flow of charges from one side to other side, until the formation of dipoles. Hana boliye. Until the formation of the dipoles only there is a movement of charges from one side to other side we have. Once the dipoles are formed, there is no flow of charges. अगर आपने ध्यान से देखा तो here, so at t is equal to 0 we have started. At t is equal to 0 we have started, and there is a movement of charges from one side to other side from t is equal to 0 to some time. So here at t is equal to 0 is started up to some time, up to this time. So we have a current, we have huge amount of charges will flow now. Huge amount of charges will flow from one side to other side. Huge amount of maximum charges are flowing. That means what we can say now here, then I can call we have a current is very high current we have. Then we have a very high current is there. Now after some time, after the formation of dipoles, that means what happens, tell me, thereafter do we have any flow of charges are taken place? After some time, after the dipoles are formed, do you have any flow of charges, you tell me? There is no flow of current, now tell me, that current completely will become zero, now tell me. After the dipoles formed, then current is zero, and during the process of dipole movement, during the process of dipole formation, maximum charges will flow from one side to other side. If the huge amount of charges are flowing, then what I can say now, we have huge current is there. Generally for the formation of these dipoles will take a time of general time, which will take a time of 5 time constant. For the formation of dipole, it will take a time of 5 time constant will take. Then what happens now, what I can say, there is a flow of charges from one side to other side until the formation of dipole. That means until up to a time of 5 time constant only, tell me, up to in this time only there is a flow of charges. Here only we have a flow of current is there. After that there is no current. In this region we have a huge current is there, maximum current is there. So this maximum current situation, maximum current is will happen generally resistance value 0. Generally when we have maximum huge current is there, maximum current when the resistance is 0. So I can say here we have current is maximum. Can I treat this as like a short circuit? And once a dipole has been formed, then there is no further flow of current, you tell me. There is no flow of current means current 0 means, which we can treat this as a open circuit. We can treat करेगा हमने बोलिए. So then we can treat that as a open circuit, we can treat. So अभी बोलिए ना इधर, अभी बोलिए मैंने अभी क्या डिस्कस किया इधर, अभी बोलिए ना हियर हमने क्या डिस्कस किया अभी तक ना, देखो इधर. So now you tell me now here, now final conclusion क्या है now here, there is a flow of current through the capacitor when we apply DC supply. When we apply what supply here, we apply now here DC supply up to certain time only, that is until the formation of dipole. The formation of dipole के लिए कितना टाइम लगेगा, 5 tau लगेगा. So here, so in up to this 5 tau only there is a flow of charges, there is a huge current is there. So up to 5 time constant we have a maximum current is there. इसीलिए we treat that nature we can treat it as a short circuit nature. इसके बाद so कोई current नहीं flow करेगा. If there is no current, we can treat that as an open circuit. Right. So the time constant means, so here now, so the time taken to do certain activity. Okay. So here time constant के बारे में, so here you will get to know more clarity in your control system. So as of now you just remember, so here time up to some time it will takes place. So this time which we used to call it as a, this is now up to 5 time constant only there is a flow of currents will be there. That flow of current is called as a, that flow of current which is called as what, you tell me, short circuit. इसीलिए we used to call, so yes, up to a 5 tau, so we have the state This scenario, which we used to call this as a transient state, is called as, what you tell me now here, this is called as a transient state. Yes, and this state from here to here, this is called as a steady state. This is called as a steady state. Now transient state, what is the transient state, you tell me now here. During the formation of dipole, see what's going to happen. One side we have huge amount of positive charge, other side we have huge amount of negative charges will move from one to other. Hana boliye. So during the process of movement of charge, there is a lot of collisions will takes place. There's a lot of collisions will takes place in the movement, in the path. So because of that, you can find some sparks, you can find, that is called as that collisions, which is called as, because of the collisions the system will become unstable. But once the dipoles has been formed, that means what now here, there is no any further movement of charges, the charges are kept stationary completely, there is no movement of charges now. So that scenario, which we used to call this as a steady state, that scenario which we used to call this as a steady state. Is it fine, all of you tell me? कोवलेंट बैंड में होता है, इसीलिए हमने सप्लाई किया ना अपना, इसीलिए so here अगर so इसीलिए so here when you don't apply any energy, so here there is no flow of charges, there is no movement of charge, free charges नहीं ना. so here ये free charges को कोवलेंट बॉन्ड ब्रेक करने के लिए so हमको कुछ एनर्जी चाहिए, ये एनर्जी इसीलिए हमने वोल्टेज दिया ना, वोल्टेज देने के बाद so this is electric field is induced here, that electric field will breaks, that electric field will breaks the bonds, then it will start flowing, इसीलिए charge movement will takes place ना, right? Is it fine, all of you tell me now इधर, अभी आपको ये बात पता चला इधर. This is the actual mechanism for the flow of, this is the actual mechanism of the working of a capacitor. That's the reason we used to call, yes, that at t is equal to 0 minus what happened, t is equal to 0 plus what happened, that's what we used to discuss. At t is equal to 0 plus mean, that means the t is equal to 0 plus kidhar idhar na, t is equal to 0 plus means immediately after start, that means this is during the process of dipoles. In the process of dipoles, what happens now, huge amount of charges will flow from one side to other side, huge amount of charges are flowing means what I can say, that is a huge current is there, that situation, that state which we used to treat it as a transient state. So then after a long time, that means what, now t tending to infinity, so the t tending to infinity is somewhere here na, that means after the formation of dipole there is no further movement of charges. So because of this, what we can say, in case of a DC supply, there is a flow of charges up to certain time only, that time is called as a transient state. Once a dipole formed, there is no flow of charges. Exactly, right. T is equal to 0 plus, not T is equal to 0 minus, T is equal to 0 plus, capacitor is transient state. Now अभी देखो इधर, इसीलिए we used to call, so capacitor blocks the DC we used to call na, that is with respect to steady state. After the formation of dipoles we used to talk. Now you see this thing, one more thing. So here we apply the DC supply. अगर हमने AC supply किया तो क्या होगा? Let us consider we apply the AC supply, we applied, then see what's happened. AC supply case, this is the positive cycle is there, this is a negative cycle is there. अगर आपने ध्यान से देखा तो if it is AC supply, for AC supply what happened? During the positive cycle, you tell me positive cycle, so then so this is I have given now, this is the positive, this is the negative. अगर negative cycle आया तो क्या होगा, you tell me. Negative cycle के लिए, so this is a negative, this is the positive होगा ना, tell me. For the negative cycle, then see this thing, what happens, you tell me now here. So this is a negative banega, this is a positive banega. Because of this, now the electric field direction like this, positive to negative like this now. What are the process happened in the positive cycle? Completely reverse hoga. So here completely reverse hone wala na idhar. So then they will completely will reverse like this. Hana boliye. The complete now here all the positive charges. This positive charge will come to here, negative charge will move to here. The reverse process will take place now, opposite direction of movement will take place. Hana boliye. Then because of that reason we have a flow of current always in case of AC supply. For again positive cycle means again the ulta hoga. So because of that reason there is a flow of current through capacitor for AC hamesha. Always there is a flow of current. So that's the reason when we apply AC supply, capacitor cannot behave like an open circuit or short circuit for the AC supply. Only for the DC supply only capacitor will behave as a short circuit and open circuit. हाँ बोलिए this thing. Yes, जो बोला आपको चमका कि नहीं बोलो. And चलो let's move to the next one. तो अभी आपको पता चला ये ट्रांसिएंट स्टेट क्या आई, ये ट्रांसिएंट स्टेट क्या आई, स्टडी स्टेट क्या आई. अभी आपको पता चला ना, बोलो सभी को. यस दिस थिंग. चलो नेक्स्ट वन. नाउ लेट्स टॉक अबाउट द कैपेसिटर. Capacitance analysis will do. Take down. Capacitance. What is the capacitance means what? If we have a two conducting plates like this, two conducting plates, for one conductor we apply the positive charge, one conductor positive charge, and the another conductor negative charge we applied, and the medium between them is filled with some dielectric. Medium between them which have filled with some dielectric, and these two plates are separated by a distance of d. If these two are separated by a distance of d, and this has a positive charge, we can say plus q, and this has a negative charge minus q. Then so if we have a two, yes, this arrangement is called as a capacitive system. This arrangement is called as a capacitive system, and this capacitive system has the ability to store the energy. This capacitive system has the ability to store the energy in the form of electric field. This capacitive system has the ability to store the energy in the form of electric field. The ability to store the energy in the form of electric field is called as a capacitance of the capacitive system. The ability to store the energy in the form of electric field is called as a capacitance of the capacitive system. Fine, all of you. Now this capacitance of this capacitive system, which is defined as, which is given as the ratio between the charge having the any of the plates, and there is a potential difference between these two. We have now that potential difference, I am calling this as a V by V. Okay, so with a magnitude mod we have taken. This is a capacitance of a capacitive system. All of you boliye. This is the capacitance of the capacitive system. Now you see this thing, how we can modify this formula. So which is given as Q. What the Q is? The charge. According to Gauss law, Q is equal to flux, and which we can say flux, we can write it as what we can say now here, surface integration of d dot ds. I can say now according to Gauss law. All of you स्मरण आई ना ये फॉर्मूला आपको, by E. What is a E? Is a electric field. What is the relationship between the electric field and potential? E is equal to minus integration of E dot dl. Hana boliye. Here what type of integration is a line integral? What type of integration is a line integral? Since we have taken the mod, we have taken na, so that's why there is no minus sign. I can say line integration of E dot dl. Isn't it? All of you boliye. Now as we know that D is equal to epsilon E, as we know that D is given as a epsilon E. So by modifying this thing here, by replacing this thing, I can get the formula for my capacitance as epsilon is a constant, take outside, epsilon into, I can say, closed surface integration of what I can write now here, that is E dot ds. E dot ds by line integration of E dot dl. Boliye, line integration of E dot dl. All of you tell me this thing. Is it fine? Now this is the general formula we use to find the capacitance of any type of material. This is the general formula which we use to find the capacitance of any type of material. Okay. Next. Resistance. Right? Now you see this thing here. एक बार आपने ध्यान से देखा तो ये फार्मूला को हमने कुछ किया तो इधर हमको क्या मिलेगा, एक बार चेक कर लो इधर ये फार्मूला का. So here you see this capacitance here. See which is given as this is epsilon. हमने कुछ किया here. Here we have this is integration of E dot ds. Let us consider here electric field is a constant electric field. Electric field is a constant. Then what I can do here, this E we can take outside now. If electric field is constant, I can take out the E outside the integral. Then I can write this thing as E and integration of ds. Integration of ds, what I'll get to tell me now, A will come now. Surface area will come. By denominator E constant I can take outside if it is E constant, and dl which we can get it as dl means length. Length I am calling, taking this thing as a d I am taking. अगर आपने ध्यान से देखा तो इधर ये क्या आया अभी बोलिए. अगर आपने ध्यान से देखा तो सो हियर आपने ये फार्मूला आप कभी भी देखा? So have you ever seen this formula? Tell me now here. ये क्या है? This is the formula which we use for the capacitor of a parallel plate capacitor ना. This is the parallel plate capacitor. So ये formula हम use करेगा, isn't it? But लेकिन so ये formula so here derive करने के टाइम में हमने कुछ modification, हमने approximation कुछ किया. अगर आपने ध्यान से देखा तो here we have taken the electric field, we have taken it as a constant. So here, so this thing, this electric field we have taken as a constant, we have taken, that's why we take. अगर if it is not a constant, I cannot take this E directly outside, हम नहीं ले सकता ना. Since we have assumed, our assumption हमने कुछ किया, so electric field is constant, इसीलिए हमने बाहर ले लिया. But लेकिन if it is not a constant, I cannot take outside ना. So this formula which is applicable certain cases only. Okay. Next. Now let's talk about the resistance. Let's talk about the resistance. Now if we have some conductor like this is my conductor. I have taken 2 points inside the conductor. Let us say this point is A and this point is B. And if there is some potential difference between these two conductors, this potential difference I am calling as V, and there is a flow of current. Now the current will flow from higher potential to lower potential like this. Now the resistance faced by the current, when it is moving from point A to point B, resistance faced by the current when it is moving from point A to point B, that is called as the opposition faced by the current when it is moving from point A to point B is called as effective resistance in between A to B, or the equivalent resistance between A and B, and which is given as what we can say now here, the potential difference between the 2 points by the amount of current passing through the conductor. Hana, बोलिए, tell me. Now the potential difference V अभी हमने देखा, the potential difference V which we can write, of course, it's a magnitude mod we have taken, that is minus integration of what I can say now here, E dot dl. Next, and here we have current. We have how we can write the current in terms of current density J. I hope all of you know the current density J, which is given as the current per surface area di by ds. All of you remembered, I think so, this formula, amperes per meter square. So from this I can get the current as what you tell me now here, that is given as surface integration of what you tell me now here, J dot ds. बोलिए, J dot ds. And here the integration conductor is a closed surface. Now that's why it is we have closed surface integral. So abhi dekho idhar the resistance R which is given as what I can say here, since we have mod, there is no minus, and the integration of E dot dl by surface integral of J, as we know that according to Ohm's law, J is equal to sigma E. I hope all of you know the standard Ohm's law. J is equal to sigma E. So if I use this thing, sigma, conductivity of a material is a constant, take outside, and this is integration of what I can say here, E dot ds. बोलिए this thing everybody. Right, this is the general formula which we use to find the resistance of any type of material. This is the general formula which we use to find the resistance of any type of material with the units of ohms. So अगर इधर भी एक magic देख लो, here also you can see the magic here. So here also you can see this magic. You tell me now here, resistance here which is given as, अगर आपने ध्यान से देखा तो here also we consider the electric field is a constant ले लिया तो, then tell me what happens now here, which is equal to E into L by sigma into here what I will get now here, E into surface area is A ना. अगर आपने ध्यान से देखा तो ये फॉर्मूला आप पहले देखा कि नहीं बोलिए. Yes, have you ever seen this formula? Yes, this is 1 by sigma, which is nothing but what you tell me now, rho L by A. Have you ever seen this formula? बोलिए. R इक्वल टू रो एल बाई ए। सो आपने ये फॉर्मूला देखा कि नहीं बोलो। लेकिन ये फॉर्मूला हमको कहाँ से मिला, ये खास बात आई। we have to understand the things now here। ये फार्मूला where we have seen so here, but लेकिन ये फार्मूला डेराइव करने के टाइम में हमने कुछ assumptions assume किया। yes or no here we have taken this thing here, integration outside we have taken। अगर नहीं here if the electric field is not a constant we cannot take outside ना। so these are certain scenarios you need to remember, but this formula which is applicable, this is the ideal case, this formula is valid but not all the cases। isn't it fine all of you boliye? These are the general formula which we use to find the resistance of any type of material, and this is the formula which we use to find the capacitance of any type of material। अगर आपने ये दोनों में कुछ कॉस रिलेशन हमको मिलेगा, अगर आपने ध्यान से देखा तो हियर C which is given as what we can say here epsilon into closed surface integration of E dot ds, okay, by, so this is line integration of E dot dl, line integration of E dot dl। now what about the resistance, you tell me now here, which is given as, which we got it as line integration of E dot dl, E dot dl, which is by sigma into closed surface integration of what I will get now here E dot ds। now अभी आप सभी ने बोलना पड़ेगा एक साथ, बोलिए now here। now if I multiply these two हमको क्या मिलेगा बोलिए राइट साइड। अगर हमने ये दोनों के मैंने मल्टीप्लाई किया तो क्या आएगा बोलिए। यस इफ वी मल्टीप्लाई दिस टू हमको क्या आएगा चेक करके बोलिए क्या आएगा। सो हियर लेफ्ट साइड एंड राइट साइड क्या मिलेगा बोलिए चेक करो। which is given as, which will get this as epsilon by sigma आएगा चेक करो। then we'll get this as epsilon by sigma मिलेगा चेक करो बोलिए। RC which is equal to epsilon by sigma। so here this is the relationship between the resistance and the capacitance, resistance and the capacitance, okay, this is the relationship between the resistance and the capacitance। by using this relation if we know one parameter we can get the other parameters, okay, by using this relation if we know one parameter we can able to get the other parameters। then if I multiply these two, chalo, then everybody, ये था खास बात। that's a beauty of the CMT, you know here see this thing। so अगर किसी if we have any doubt so then सारा doubts का solution EMT में मिलेगा, right। so if you see carefully now we used to call RC is called as a time constant, remembered RC is called as a time constant। here also here is epsilon by sigma which is also similar to time constant but with a different name, where this epsilon by sigma similar to a time constant only काम करेगा इधर। so networks में this is the time constant but here this epsilon by sigma is a time constant, but लेकिन हम also we can use a different notation, different name we use, and this epsilon by sigma which is called as a relaxation time, epsilon by sigma which we used to call this as a relaxation time, and what are the units are seconds, the units are what seconds। done, chalo, let's move now next one। now let's talk about let's talk about the parallel plate capacitors. Let's talk about. So the relaxation time, like a time constant, here we have relaxation time, yeah. Like we used to call a time constant, tau we used to call na. Time constant means time taken to reach the 50% of the maximum value. That is a time constant. Yes, that is a time constant which we used to call. So here time constant, simple तरीका what I used to say here. Let us consider here आपने एक business शुरू किया. Let us say you started some business you have started. So now here, so here आपने, so let us say here, so एक let us say here so here एक, so here 100 rupees से एक business आपने शुरू किया. So here what is the after how many days after starting your business, and so here you will get this as a 100 rupees, at least you need to get 50% has to business has to be done. So that time which is called a, what we used to call it as a time constant, that we used to call 1 by e times of initial value. So कुछ आपने बिजनेस शुरू करने के टाइम बाद, so कुछ टाइम लगेगा ना here ब्रेक इवन आने के लिए. So that time, so that minimum 63% if to reach, that is called as a time constant. Exactly same thing in the relaxation time. Like a time constant, we have a relaxation time. Right. Now let us talk about the capacitance of a parallel plate capacitor. Now you tell me what is the capacitance of a parallel plate capacitor. अभी ने हमने देखा अभी here, which is given as epsilon A by D. All of you बोलिए epsilon A by D. Now here this is epsilon. Epsilon means permittivity of the medium between. And what is the A is the area of cross section. A is the area of cross section. And what is the D is the distance between the two plates. D is what I can say, distance between the two plates. Now here if you see carefully, when the medium between the two plates we have epsilon, let us consider the medium between the two plates is a free space. That capacitance I am calling it as C naught. Can you tell me C naught? Can you tell me the C naught value? When the medium is a free space, tell me now here free space means air. How much the capacitance you tell me? That is given as epsilon naught A by D, I can say now. Now can you tell me now here C by C naught क्या आएगा? Can you tell me C by C naught क्या आएगा? Tell me all of you. Yes. So which will get it as C by, so here which we can say this as epsilon by epsilon naught होगा ना? As we know epsilon which is given as epsilon R into epsilon naught by epsilon naught होगा ना? Where epsilon naught is the permittivity of air, epsilon R is a relative permittivity. Then what I will get now here C by C naught. What I will get, you tell me now here epsilon R मिलेगा. C by C naught which is given as epsilon R. What is epsilon R is a? What is the epsilon R? Where epsilon R is called as what, you tell me? Relative permittivity. Epsilon R is called as a relative permittivity. Epsilon R is called as relative permittivity. This epsilon R which is also called as a dielectric constant. Epsilon R को कुछ another name, that is a dielectric constant. Epsilon R is also called as a dielectric constant of the dielectric medium. Okay. Done? Right. चलो. Now you see this thing, हम कुछ कॉस्ट भी डिस्कस करने वाला इसके इधर. ऑल ऑफ यू ध्यान से देखो इधर. Yes. Now let us consider, here we have, let us say this is my capacitor. This is my capacitor. Now here, let us say now the distance between the two conducting plates, which is equal to D, and the area of cross section, which is equal to A. Area of cross section is A. What is area of one plate? Now you see this thing here. What I did, you know, here the medium between them is filled with some dielectric. इसका gap ने कुछ dielectrics ने मैंने fill किया. But लेकिन what I did now here, so I didn't fill the complete medium with the same type of one type of medium. मैंने इसको कुछ parts divide किया. यहाँ तक let us say मैंने 3 parts divide किया. So here this is filled with one type of medium, let us say epsilon 1. Area to be considered. How many areas आपको दिख रहा है? How many areas you are seeing? You tell me. How many areas you can see now? This is the plate. This is the plate now here. This area is A now here. How many areas you can able to see? Tell me. Now here this above part of area, below part of area, both are same. Remember. Okay. Now this part is filled with some epsilon 1 and this is filled with some other medium. Let us say this is filled with some epsilon 2 and this is filled with some other medium epsilon 3. Filled with 3 different type of mediums मैंने fill किया. Now I need the overall capacitance is required. Now I need what now here? I need the overall capacitance. So because of the filling this thing here, अगर आपने ध्यान से देखा तो here, now what happened to the capacitance I want to find? Tell me the capacitance which is given as, what you tell me? So in general capacitance is given as epsilon A by D. हाँ ना बोलिए? Epsilon A by D. Now you tell me now here, so here this epsilon is there now one parameter. This is always changes. अगर आपने मैंने ऐसा fill किया, you tell me now here, in this इस दोनों में apart from epsilon, what are the variable quantities here? Tell me. Which are variables now? D changes or A changes? You tell me. What are the variable quantities? D changes or A changes? In this now here, मैंने ऐसा division किया. So what will changes now? Area of the plate will changes or distance of separation will changes. So if you see carefully, the D is a distance between now यहाँ से यहाँ तक. This is a distance is D. This distance also D. This distance also D only. Now what changes you can see? So मैंने ऐसा divide किया तो here area of the plate will changes or not? Area of the plate will changes, yes or no? How this plate here? So you try to understand now here. So here this is a capacitor. So this is a plate now, tell me. What will changes you tell me now here? Area. मैंने ऐसा divide किया. मैंने ऐसा divide किया. Try to visualize properly. One plate over the other plate. Means now in this case only this part is one medium now here. Only this part area. Total area is A. So A change this part area. 3 different type of areas होगा ना? Tell me all of you. Yes, now as a result what happens now, this area which I can say this is A1 होगा and this area is a A2 होगा, this area is a A3. all of you बोलिए 3 areas बनेगा बोलिए. Now since here you see this thing here, what are the variable parameters here? what are the variable parameters here? Epsilon तो changes ना हमेशा, epsilon 3 different medium epsilon changes and A changes, and whichever the parameter changes group them, those variable parameters को group करो and whichever the things are not changes इसको अलग करो. Here these two changes इसको group करो and this fellow not changes ना denominator not changes ना इसको अलग करो. Then now what I can say now, the overall capacitance C which is given as these two, this value changes, this value changes. How I should write now here? Epsilon is epsilon 1 for this case, and what now here? A means what we can say A1, but D not changes now, D as it is D1. So here D not changes now, here D value constant, so I am taking the D outside simply. Remaining you can write now. First case what we can say here, epsilon is what you tell me, epsilon is epsilon 1, A means A1, plus second one, in this case epsilon is what you tell me now here, epsilon 2, A means what we can say here, A2, boliye. And this one epsilon is what we can say, this is epsilon 3, A means what we can say now, A3, boliye this thing. Is this point clear to all of you? That's all. Now अगर आपने ध्यान से देखा तो this thing which we can also split it as, this is epsilon 1 A1 by D. So this is epsilon 2 A2 by D and plus epsilon 3 A3 by D. All of you boliye. This which is given as C, which is given as what I can write now here, this is nothing but C1 plus C2 plus C3 हो गया ना बोलिए, which is nothing but C1 plus C2 plus C3 ना here. Now I have capacitors we have directly added, that means how this capacitors has been connected you tell me, which is given as epsilon 1 A1 by D, this is C1, and the C2 given as, tell me now here, epsilon 2 A2 by D. Next C3 is given as what I can say, tell me, epsilon 3 A3 by D. So how this capacitors has been connected you tell me here. So this means what we can say here, these are connected in parallel होगा ना. Now you tell me now here. So now you tell me in parallel connection, how the voltage across each plate. This is my voltage potential V now. What is the potential across each capacitor you tell me? What is the potential difference in case of each capacitor? Same or different? Potential across each plate which is same or different? Potential same. Yes. Whatever the flow of current, current different or not, current changes. आना बोलिए. Now potential and so charge, whatever the charge is also different or not. In this case what happens now, if I say some charge here, some current is coming here, this current is I, so क्या होने वाला, इधर आने के बाद इस पाथ में कुछ करंट जाएगा, इस पाथ में कुछ करंट जाएगा here, 3 different currents will go to 3 directions होगा कि नहीं? Right. Now current is different. Done. So one important observation अभी ये लिखो. You see this thing here. So in parallel connection, how the voltage, tell me now, voltage across each capacitor is same. Voltage across each capacitor is same. Voltage same. Whatever the electric field for the two-dimensional case, electric field which we can say this as E is equal to V by D na. 1D case we can write E is equal to V by D. You tell me now here, potential across each plate is same na. Potential same, and D, whatever D now, distance between the plates. Now in all the cases D same or not? In all the cases D same na, V also same, V by D also remains same na. That's why I can say electric field is same. Isn't fine? And whatever the current same or divides? What about the current? You tell me now. Current will divide now, tell me. Current divides means whatever the charge you tell me. Charge will divide hoga. So this is the loop. If the charge divides, charge has a different path to go, then obviously we can call the connection as a parallel connection. If the charge is dividing, means charge having a different path to go, then what I can say now here, I can say that is a parallel connection hoga ki nahi bolo. That what, this is the loop. You know here, this is one of the very important observation. You see this thing here based upon this loop. And so here, so we have a GATE 2014, GATE 2015 and GATE 2017 and GATE 2019 में प्रॉब्लम आया बेस्ड अपॉन दिस कॉन्सेप्ट में. एक कॉन्सेप्ट, ए लूप आपको समझ में आए तो हियर डायरेक्टली यू कैन गिव द आंसर. 14, 15, 17, 19 में प्रॉब्लम आया. ओके डन. Fine, all of you? Now here you need to remember this thing as the next time onwards. So you need to remember this analysis as like this. ध्यान से देखो इधर. And so tomorrow we are going to discuss another type of capacitors. For that you need to have this understanding is required. Yes, you tell me now, this is one capacitor. Now here this is a positive, this is a negative. All of you boliye. Here this is one capacitor C1. This is the C2, this is the C3. All of you boliye. Listen carefully here. One important observation here. Now you see this thing here. This whole thing is single conductor. This whole thing is single conductor only na boliye. This is single conductor only. So this conductor, this thing, what I can treat now here. So this conductor, what I am treating as. So here this thing, we have direct connection is there. And I treat now here. We have connection is there. I can treat now. And from here to here we have this connection is there. I can treat now. Now this all the positives. So this is the positives now here. All this is a positive. This is a positive. This also positive only now. Can I say this? All these positive terminals has been connected. All the positive terminals has been connected. Now this is also one single conductor. I can treat this thing as this is conductor. This connection is there. This connection is there. I can treat now. Now this is a negative. This is a negative. This is also negative. Now you see this thing. All negatives has been connected. all negatives has been connected. Now you tell me, all positives connected, negative connected. That means what type of connection I can say that one? What type of connection I can call it is a positives connected, negatives connected. Means what type of connection you tell me? I have this is the positive, and next again positives connected, negatives connected. ऐसा हुआ ना? Then what I should call this type of connection is a parallel connection, isn't it? So like that we can understand this thing. Is it fine, all of you? If all positives connected, all negatives connected, then we can call that as a parallel connections, isn't it? Next one. Now you see the second observations. The second observation. Now here we have, this is a capacitor. Now what I did now here, I am dividing this capacitor into like these parts. I am dividing this part as a this is. Now this is filled with one type of medium, this is filled with one type of medium, this is filled with another type of medium. You tell me now as a result क्या होने वाला, you tell me. As a result, the whole distance of separation, which is what you tell me now, d na, the distance of separation is d. Because of this division, what I can say now, this distance which will become d1 hoga, this distance is d2 हुआ, this distance is d3 हुआ, and what else I can say now, d1 plus d2 plus d3, which is equal to what I can say, d. And what else I can write now, tell me now, this area, any change of area, tell me. Plate area not changes now, tell me. No change of this plate area. Done. As I told you the trick, I told to do the analysis now here. What is the capacitance formula which is given as epsilon A by D? अभी देखो इधर, what are the variable parameters, what are the constant parameters, you tell me. इसमें so what are the variable parameters and what are the constant things here? Yeah, what are the variables and what are constant, you tell me. Here what are the variables and what are constant, you tell me. So epsilon the variable now, first thing. What about the area changes or D changes here? Here what changes? Area changes or D changes? Here D changes, area constant na here. Then I told you na, so here whichever the variable parameter isko combine karo, and constant parameters one side and variable parameters one side. Now abhi bolo, now I can modify this formula C, which I am writing it as A by, I can write this thing as D by epsilon. कोई problem I तो बोलिए अभी. Can I write like this? Yes, why? Because D and epsilon changes ना, so इसको मैंने group किया. These two are friends. Here these two are variables ना, these two are friends. Friends को separate करो. So D by epsilon को group करो. ठीक है? So अभी बोलिए now here what I can write now, this capacitance. I can write the C which is given as, tell me now, ये तो constant ना सारा को, for all the cases ये is constant. हाँ ना बोलिए. Now here this को इसके, so here what you tell me now here, for this one d1 by epsilon 1 बोलिए, plus d2 by epsilon 2 बोलिए, plus d3 by epsilon 3. Isn't it, all of you tell me? आना बोलो. d1 by epsilon 1, d2 by epsilon 2, d over, that's all. Is it fine? So this is the manner we can able to find the overall capacitance. हो गया सभी को बोलो. Now अभी analyze कर सकता. Now you tell me now here how the connection of this capacitors, you tell me. Abhi, so this is like a C1 capacitor, this is a C2 capacitor, this is C3 capacitors, right? How this capacitors has been connected, you tell me. Now this is the positive plate and this is a negative connection. Supply na tell me. Now you tell me now here. This is a positive high to, so here kya hoga? How the connection you tell me now, all the capacitors connected. The current will flow, same path will flow na. Current ko liye humko ek hi path hai na here. So that means what we can say, the same current is flowing means which we can say series connection. Series connection done. So in series connection, this is the equivalent capacitance. As we know, series connection, what is the overall capacitance now here? 1 by C equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3. Now that's what we should write. Now, baby, either. Now in this case, what I need to analyze now here, you see this thing here. This is dielectric is there now. Dielectric, one side will become positive, other side will become negative. When you have given positive, this is the positive. And here this is dielectric, this side negative hoga and this side positive hoga. Negative and this side positive. Like this dielectric will behave. Now you tell me now how the connection is there, you tell me. Now this line will behaving like a negative positive. Yes sir, now tell me how the connection now here. Negative and positive connected. Negative and positive connected. Then how the connection you tell me? So means I have a positive terminal and negative terminal we have. इसके लिए मैंने positive and negative connect किया and positive and negative connect किया. If I did this connection, so this is my V1, this is my V2, this is my V3 होगा ना, tell me. So but लेकिन इस सारा में current is what you tell me now. I can treat this as single current will flow ना here. एक ही current will flow. Then how the connection I can say? Series connection I can say na. That what? In series connection, what I can say now, tell me. Series connection, current same or not? And whatever the charge, same charge will flow na, will flow all the capacitors. Same charge will flow. Right. Current same, charge same. But what is the potential, you tell me? But the potential will changes or not? V1, V2, V3 होगा ना. So different potentials will flow. Different potential differences are different. Done. Now you can see in series connection, you tell me now, Abibi. Series connection, what I can say here? Current same. Series connection, current same. Current same, charge क्या होगा? Charge भी same है ना? अभी देखा? Series connection, current same, charge same. And but what about the voltage? Potential will divide na. Potential divide means electric field will be divided hoga. Isn't it? This is also one important observation. Based upon this also they given a problems very frequently. 2014 onwards they are given. 14 में आया and the 15 में आया and 16 में आया based upon this thing. And then so this is so here 19 में भी आया based upon this. Very frequent problems. Okay. So today we have discussed about this parallel plate capacitors. Tomorrow we are going to talk about the cylindrical and spherical capacitors. And so here आप सभी ने सारा रिवाइज करके कल तुम्हारा क्लास को आओ, then आपको अच्छे से समझ में आएगा. Fine. Yeah. I hope all of you enjoyed the today's class. I hope all of you all the सारा topics clear होगा. So here everybody enjoy the class, I think so. Then fine. So here problems and all will solve in the special classes we can solve. In Unacademy special classes we can solve the problems. Okay, some problems we can solve in here in the YouTube. And so here I have given a DPP. Now DPP 400 problems are there. Those will be solved in the special classes. Fine. Okay then, yeah, that's for the today's session. We'll meet tomorrow. Okay then, see you, bye bye, good night.